August 29th, 1945. Tokyo Bay. The USS Segundo surfaces 1,200 yards from a submarine longer than a destroyer. Commander James Donald Fulp trains his binoculars on the approaching vessel. The numbers don't make sense. 400 feet from bow to stern. Displacement exceeding 5,900 tons. A cylindrical structure sits forward of the conning tower, 102 feet long and 11.5 feet in diameter. Fulp's intelligence briefings mentioned rumors of Japanese submarine aircraft carriers, vessels carrying floatplanes in watertight hangars. American cryptanalysis intercepted messages about a mission to bomb the Panama Canal. Naval intelligence dismissed most reports as either propaganda or misidentified reconnaissance aircraft operating from remote island bases. But this submarine matches the descriptions exactly. It flies a black surrender flag. The designation I-401 appears in white paint on the conning tower. Fulp orders his crew to battle stations anyway. At 400 feet, this submarine displaces more tonnage than most American destroyers, carries a crew exceeding 140 men, and mounts deck guns larger than anything American submarines carry. If the surrender is a ruse, if this is a suicide attack disguised as capitulation, the Segundo and every ship in Tokyo Bay faces a threat unlike anything seen in the Pacific War. The massive submarine closes to 800 yards. Fulp sees Japanese sailors on deck, hands raised, white flags visible, no hostile movement, no weapons trained toward American vessels. The submarine's captain stands on the bridge, saluting. Through the binoculars, Fulp sees the officer's face. The expression isn't defiance or hatred. It's exhaustion combined with something else. Relief, perhaps, that the war has ended without executing the mission for which this vessel was designed. Fulp didn't know it yet, but the submarine approaching his position represented Japan's last desperate attempt to strike American territory directly. 3 massive aircraft-carrying submarines had departed Ominato Naval Base weeks earlier, their orders to launch coordinated bombing attacks against the Panama Canal. The mission, codenamed Operation Hikari, planned to disrupt the vital waterway connecting Atlantic and Pacific naval forces. American intelligence learned of the mission through intercepts, but couldn't determine the submarine's exact locations or strike timing. Then, on August 15th, Emperor Hirohito's surrender broadcast ended the war. The I-401, along with sister vessels I-400 and I-14, received orders to surface, destroy all aircraft and sensitive equipment, and proceed to designated surrender points. Captain Nambu commanded I-401 into Tokyo Bay, knowing American forces would capture the most advanced submarine technology Japan possessed. What neither Fulp nor Nambu understood that morning was how completely this technological marvel had failed strategically. The I-400 class submarines represented years of engineering innovation, consumed scarce resources desperately needed elsewhere, and accomplished absolutely nothing operationally. They never fired a shot in anger. They never executed their intended missions. They became symbols of Japanese strategic confusion, technological prowess wasted on weapons that couldn't influence the war's outcome. The I-400 submarine program originated in January 1942, following Japan's initial successes at Pearl Harbor, the Philippines, and throughout Southeast Asia. Admiral Isoroku Yamamoto, Commander-in-Chief of the Combined Fleet, convened senior naval staff to discuss extending Japan's strategic reach beyond the Western Pacific. Intelligence reports indicated that American industrial mobilization was proceeding faster than Japanese planners anticipated. Yamamoto believed Japan had perhaps 18 months before overwhelming American material superiority made Japanese victory impossible. He needed weapons that could strike American territory directly, disrupting logistics, destroying infrastructure, and potentially forcing negotiated peace before American strength became insurmountable. Commander Yasuo Fujimori, an innovative submarine designer who had worked on previous long-range submarine projects, proposed an audacious concept. A submarine large enough to carry 3 floatplanes in a watertight hangar, capable of reaching any point in the world, with sufficient range to circumnavigate the globe without refueling. The submarine could approach American coastlines undetected, launch aircraft for bombing raids, recover the aircraft, and escape before American forces could respond. Fujimori's calculations showed that 3 such submarines, each carrying 3 aircraft, could strike coordinated attacks against critical infrastructure. Panama Canal locks, major port facilities, industrial centers, and even cities like New York, Los Angeles, or San Francisco theoretically lay within range. The Naval General Staff approved the program in March 1942 with orders for 18 submarines. The designation Sentoku, or I-400 class, reflected their unprecedented size. Construction contracts went to the Kure Naval Arsenal and Sasebo Naval Arsenal, Japan's 2 largest submarine construction facilities. Cost estimates projected 45 million yen per submarine, approximately 3 times the cost of a standard fleet submarine. The technical requirements exceeded anything Japanese engineers had attempted previously. The I-400 submarine measured 400 feet 3 inches in overall length, with a beam of 39 feet 4 inches. The pressure hull diameter reached 32 feet 10 inches, creating internal volume comparable to some surface warships. Surface displacement totaled 5,223 tons, increasing to 6,560 tons submerged, making these vessels the largest submarines constructed by any nation until nuclear-powered ballistic missile submarines appeared in the 1960s. 4 7,700 shaft horsepower diesel engines powered twin propellers through reduction gears, generating 18.7 knots surface speed. Electric motors producing 2,400 shaft horsepower provided 6.5 knots submerged speed, though practical underwater operations rarely exceeded 3 knots to conserve battery power. Range calculations showed 37,500 nautical miles at 14 knots surface speed, enabling the submarines to reach any ocean on Earth. Fuel capacity totaled 1,600 tons of diesel oil, supplemented by 90 tons of lubricating oil stored in segregated tanks throughout the hull. Freshwater capacity of 45 tons supported the crew of 144 officers and enlisted men during patrols lasting up to 90 days. The engineering represented mathematical precision translated into steel reality. The aircraft hangar dominated the submarine's forward section, a cylindrical structure 102 feet long and 11.5 feet in diameter, running at an angle along the submarine's centerline. The angle, 3 degrees above horizontal, facilitated water drainage when the hangar was opened at sea. Watertight doors at both ends sealed the hangar completely, allowing the submarine to dive with aircraft secured inside. The doors used pneumatic actuators powered by compressed air at 500 pounds per square inch. Opening or closing required 45 seconds, carefully timed sequences that had to be executed perfectly or risk flooding the entire hangar. The hangar could accommodate 3 Aichi M6A1 Seiran floatplanes with wings folded and floats attached. Each aircraft measured 28 feet 7 inches long with wings folded, just barely fitting inside the hangar's dimensions. The storage arrangement resembled a puzzle requiring precise positioning. 1 aircraft faced forward, 1 aft, and 1 positioned between them. Removing 1 aircraft meant the other 2 couldn't be accessed without shuffling positions. Launching all 3 aircraft required approximately 45 minutes under ideal conditions, assuming perfect crew coordination and calm seas. The M6A1 Seiran represented specialized naval aviation engineering. Aichi Kokuki designed the aircraft specifically for submarine operations, optimizing for rapid assembly rather than performance. The floatplane measured 38 feet 2 inches long with wings extended, spanning 40 feet 7 inches. Empty weight totaled 7,562 pounds, increasing to 9,526 pounds. With full fuel, and a single 1,874-pound bomb or torpedo. The Aichi M6A1 32 14-cylinder liquid-cooled engine produced 1,400 horsepower, generating 295 miles per hour maximum speed at 17,225 feet altitude. Range calculations showed 740 miles with standard fuel load, extendable to 970 miles with auxiliary tanks. Combat radius calculations became more complex. Launching from a submarine required flying to the target, conducting the attack, and returning to the submarine's position. The submarine couldn't remain stationary while waiting for returning aircraft, requiring constant position adjustments to avoid detection. Realistic combat radius estimates suggested 250 to 300 miles maximum, limiting target selection significantly. Aircraft assembly procedures required intensive crew training. Each Seiran required 30 minutes to remove from the hangar, unfold wings, attach floats, conduct pre-flight inspections, fuel, arm, and position on the catapult. The process involved 15 sailors working simultaneously on different assembly tasks. Wings locked into position using quick-release pins that engaged automatically when fully extended. Control surfaces were checked for full range of motion. The floats, stored separately in the hangar, attached to the fuselage through 4 mounting points that had to align perfectly or create dangerous structural stress during water landings. Launching used a Type 4 number. 2. Model 10 compressed air catapult rated at 60,000 pounds of thrust. The catapult cylinder measured 85 feet long, mounted along the submarine's deck forward of the conning tower. Compressed air stored at 800 pounds per square inch drove a piston connected to a shuttle that engaged the aircraft's fuselage. Launch acceleration reached 90 miles per hour in 85 feet, generating approximately 5 Gs of force. Pilots had to brace for launch while maintaining control of the aircraft throughout the acceleration. The aircraft became airborne immediately after leaving the catapult, the floats preventing landing gear damage during the violent acceleration. Recovery presented greater challenges. The aircraft landed alongside the submarine, taxied to a recovery crane, and was hoisted back aboard. The crane capacity of 5 tons barely exceeded the Seiran's maximum weight, creating dangerous situations if the aircraft returned damaged or with unexpended ordnance. Recovery required calm seas with waves below 3 feet. Wind speeds exceeding 15 knots made recovery dangerous. Darkness made recovery nearly impossible. These constraints meant operational windows for missions remained extremely narrow. Armament reflected the submarine's dual role as aircraft carriers and conventional attack submarines. The main deck gun, a Type 11 140mm naval rifle, fired 84-pound shells to ranges exceeding 19,000 yards. Ammunition storage totaled 30 rounds, insufficient for sustained surface actions, but adequate for merchant vessel attacks or defensive fire against aircraft. The gun crew numbered 15 men, requiring 10 minutes to man the weapon from secure submarine conditions. 3. Triple 25mm Type 96 anti-aircraft guns provided air defense, mounted on platforms around the conning tower. Each gun fired 260 rounds per minute to effective ranges of 3,300 yards. Practical accuracy against maneuvering aircraft remained poor, typical of manually aimed weapons without fire control systems. The 25mm guns represented last-ditch defense rather than effective anti-aircraft protection. Torpedo armament included 8 21-inch torpedo tubes, 4 bow tubes, and 4 stern tubes mounted externally in the submarine's casing. Torpedo storage totaled 20 Type 95 torpedoes, oxygen-powered weapons capable of reaching 49 knots for 10,000 yards. The Type 95 represented advanced torpedo technology, using pure oxygen instead of compressed air to eliminate the visible wake that betrayed torpedo attacks. However, oxygen torpedoes were temperamental, sensitive to shock, and prone to explosion if improperly maintained. Several Japanese submarines were lost to accidental torpedo detonations caused by oxygen system failures. Electronics included Type 13 air search radar, with detection range of approximately 60 miles against aircraft. The radar provided warning of approaching threats but lacked the range or precision of American systems. Type 22 surface search radar detected ships at ranges up to 25 miles under ideal conditions. Reliability problems plagued both systems, with frequent breakdowns requiring extensive maintenance. Sonar systems remained primitive compared to American equipment. Japanese passive sonar could detect propeller sounds at ranges exceeding 10,000 yards, but provided poor bearing accuracy. Active sonar, used sparingly to avoid detection, reached effective ranges of 2,000 yards. The absence of sophisticated sonar limited the submarine's ability to track targets or detect approaching threats. Construction of the first I-400 submarine began at Kure Naval Arsenal on January 18, 1943. Commander Toshio Kusaka oversaw construction as the Kure Naval Arsenal's submarine construction supervisor. He faced immediate challenges coordinating the massive project. The I-4O's size required constructing 3 separate hull sections that would be joined during final assembly. Each section weighed over 600 tons, requiring specialized cranes and transport equipment. The hull used high-tensile steel 20 mm thick for the pressure hull, increasing to 30 mm in critical areas. Welding such thick steel required specialized techniques that few Japanese welders possessed. Kusaka established training programs to certify welders specifically for I-400 construction. Quality control became critical. A single defective weld in the pressure hull could cause catastrophic failure during deep dives. Inspectors used X-ray equipment to examine every pressure hull weld, rejecting sections that showed any flaws. This meticulous approach slowed construction, but prevented fatal structural failures. The aircraft hangar presented unique engineering challenges. The cylindrical structure had to maintain watertight integrity under diving pressures, while providing adequate internal clearance for aircraft storage. Engineers designed a double-wall construction with the inner wall forming the structural pressure hull and an outer fairing creating the streamlined external profile. The gap between walls contained piping, electrical conduits, and ventilation ducts. The hangar doors represented the project's most complex mechanical systems. Each door measured 14 feet in diameter, fabricated from 40 mm steel plate, reinforced with internal bracing. Pneumatic actuators powerful enough to move the massive doors required high-pressure compressed air systems that added weight and complexity. Testing revealed that the doors leaked slightly under pressure, requiring additional rubber seals and multiple locking points. Even with modifications, the hangar doors remained the submarine's most vulnerable point. A single failure could flood the hangar and potentially sink the submarine. Propulsion systems installation occurred in parallel with hull construction. The 4 main diesel engines, Type 22, Model 10 units built by Mitsubishi, arrived at Kure in March 1943. Each engine weighed 35 tons, requiring careful positioning within the engine room. Alignment between engines, reduction gears, and propeller shafts had to be precise within millimeters, or vibration would destroy bearings during operation. Battery installation presented logistical challenges. The submarine carried 2 banks of batteries, 224 individual cells, each weighing 1,600 pounds. Total battery weight exceeded 280 tons, representing nearly 5% of the submarine's submerged displacement. Battery rooms required ventilation systems to remove hydrogen gas produced during charging. Inadequate ventilation could create explosive atmospheres that destroyed several German and British submarines during World War I. Commander Tatsunosuke Ariazumi assumed command of the I-400 during its final construction phases in December 1944. A veteran submarine officer with extensive Pacific experience, Ariazumi had commanded I-8 during the Indian Ocean campaign. where his submarine sank over 30,000 tons of Allied shipping. His appointment reflected the Naval General Staff's expectations that I-400 would execute high-priority strategic missions requiring experienced leadership. I-400 completed sea trials in January 1945, nearly 2 years after construction began. The original 18-submarine program had been reduced to just 5 boats as Japan's strategic situation deteriorated and resources became scarce. Only 2 submarines, I-400 and I-401, achieved operational status before the war ended. I-13 and I-14, modified versions carrying 2 aircraft instead of 3, were completed later. I-402, the 5th submarine, remained incomplete at Sasebo when Japan surrendered. The reduction from 18 submarines to effectively 2 operational units revealed Japan's collapsing industrial capacity. Steel allocation for submarine construction competed with battleship repairs, carrier construction, and hundreds of other military programs. Skilled labor shortages meant construction crews worked extended shifts, increasing accidents and quality problems. Supply chain disruptions delayed delivery of critical components. Electric motors scheduled for October 1943 delivery arrived in February 1944. Periscopes ordered in December 1942 were delivered in August 1944. The cumulative delays meant I-400 entered service when Japan's strategic situation had fundamentally changed from the optimistic projections of January 1942. Training exercises revealed operational limitations that designers hadn't fully considered. Diving time from surface to periscope depth averaged 56 seconds, slower than the 45-second specification. The submarine's massive size created handling challenges during submerged operations. Trim adjustments required precise calculations and careful execution. Emergency ascent maneuvers took longer than conventional submarines. Surfacing in heavy seas proved dangerous, with waves breaking over the hangar doors before the submarine fully surfaced. Captain Nambu, who commanded I-401, later described the training period to American interrogators. We drilled constantly on aircraft launch and recovery procedures. In calm seas with experienced crews, we could launch all 3 aircraft in 30 minutes. But adding combat stress, potential enemy contact, rough weather, and the reality that mistakes would kill people made the procedures far more difficult. We never successfully launched and recovered all 3 aircraft in a single training exercise. Something always went wrong. A crane malfunction, an aircraft engine failure, a door seal leak. The complexity exceeded our operational capability. Intelligence reports reaching American naval headquarters in Pearl Harbor throughout 1944 contained fragmentary information about Japan's submarine aircraft carriers. Captured documents from Kwajalein mentioned large submarines capable of carrying aircraft. Radio intercepts referenced submarine aviation units and mentions of aircraft launches from submarines. Prisoner interrogations provided confused accounts of submarines larger than destroyers with strange cylindrical structures. Commander Edward Martin Eller, assigned to the Office of Naval Intelligence's Submarine Analysis Section, compiled these reports into an assessment circulated in June 1944. The document concluded that Japan was developing or had developed extremely large submarines capable of carrying seaplanes, though specific details remained unclear. Eller's analysis noted that such submarines represented potential strategic threats if used to attack Panama Canal locks or West Coast industrial facilities. However, the assessment questioned whether Japan possessed sufficient resources to build these vessels in meaningful numbers. The American submarine campaign against Japanese shipping was destroying merchant vessels faster than Japan could replace them. Industrial capacity was being diverted to desperate defensive measures. Building large, specialized submarines seemed inconsistent with Japan's deteriorating strategic position. What American intelligence didn't know was that the I-400 submarines were operational and that Japanese naval planners were developing specific strike plans. The Japanese Naval General Staff considered multiple targets for the submarine aircraft carriers. Initial proposals focused on striking American industrial centers on the West Coast. Los Angeles harbor facilities, San Francisco shipyards, and San Diego naval bases all appeared on target lists. The Seiran aircraft, carrying 1,874-pound bombs, could cause significant damage to port facilities if strikes were precisely timed. However, operational analysis revealed fatal flaws in these plans. The submarines would need to approach within 250 miles of American coastlines to launch aircraft. American coastal radar networks, extensive naval patrols, and intensive anti-submarine warfare operations made such approaches extremely dangerous. Even if the submarines successfully launched aircraft, the probability of recovering them after the attack approached zero. American forces would be fully alerted, making submarine operations in coastal waters suicidal. The attacks would be one-way missions for both submarines and aircraft. Japanese planners struggled with the mathematics. 3 submarines, 9 aircraft, maximum bomb, load 16,866 pounds total. American industrial capacity exceeded 50% of global production. Japan's entire strategic submarine force, risked on a single mission, might destroy several warehouses or damage dock facilities. American construction crews would repair the damage within weeks, while the submarines and their irreplaceable crews would be lost forever. The strategic return didn't justify the investment. Alternative targeting shifted toward the Panama Canal, a vulnerability that Japanese planners had considered since the war's beginning. The canal represented a critical choke point connecting American Atlantic and Pacific naval forces. Destroying or damaging the locks would force American warships to transit around South America, adding weeks to deployment times and potentially disrupting operations in both theaters. The Panama Canal's lock system presented attractive targets from an engineering perspective. Each lock chamber measured 1,000 feet long and 110 feet wide, with concrete walls 60 feet thick at the base. The gates, massive steel structures weighing 700 tons each, controlled water flow between lock chambers. A direct hit from a 1,874-pound bomb might damage or destroy a gate, rendering that lock inoperable. Even if the bomb didn't destroy the gate completely, repairs would require weeks or months, disrupting American naval logistics during the critical period. Lieutenant Asamura Inoue, assigned to the Naval General Staff's planning section, developed the operational plan for Operation Hikari, the codename for the Panama Canal strike. The plan called for I-400, I-401, and I-13 to depart separately from Japanese waters, rendezvous at a predetermined point in the Pacific, and approach the canal simultaneously from different angles. The submarines would surface 250 miles offshore during pre-dawn hours, launch aircraft, and submerge immediately. The Seiran floatplanes would approach the canal at wave-top height to avoid radar detection, climbing only during the final attack run. Each aircraft would target specific locks, with all 9 aircraft striking within a 15-minute window to overwhelm defences. The plan's elegance concealed fundamental operational problems. First, coordinating 3 submarines to arrive at a rendezvous point simultaneously after transiting thousands of miles of ocean-required navigation precision that Japanese submarines rarely achieved. Radio communication would be minimal to avoid detection, meaning each submarine would navigate independently with no ability to adjust the rendezvous timing. Second, launching 9 aircraft from 3 submarines within the narrow time window required perfect execution. Any delay, any mechanical malfunction, any problem with a single aircraft would disrupt the entire schedule. Third, the aircraft had to fly 250 miles at low altitude over open ocean, navigate to the canal, execute precision bombing attacks against heavily defended targets, and return to submarines that might have been forced to move or submerge. The probability of mission success, calculated by Inoue's planners using optimistic assumptions, reached only 35%. The probability that all 3 submarines would survive the mission dropped to less than 15%. Material shortages delayed Operation Hikari's execution throughout early 1945. Aviation fuel for the Seiran aircraft became increasingly scarce as American submarine attacks destroyed Japanese tankers. The high-octane fuel required for the Atsuta engines was diverted to homeland defense fighter aircraft, leaving submarine aviation units with limited supplies. Torpedoes, bombs, and ammunition were similarly rationed. Training flights were cancelled to conserve fuel. Live weapons testing couldn't be conducted because ordnance was being held for actual combat operations. By June 1945, when Operation Hikari received final approval, the strategic situation had deteriorated catastrophically. Okinawa had fallen to American forces. The Japanese Navy had effectively ceased to exist as a fighting force after the destruction at Leyte Gulf and the sinking of Yamato during its suicidal surface attack against the Okinawa invasion fleet. American B-29 bombers were systematically destroying Japanese cities through incendiary bombing campaigns. The Soviet Union was massing forces along the Manchurian border, preparing to enter the war. In this context, Operation Hikari represented desperation rather than strategy. The Panama Canal strike, even if completely successful, couldn't materially affect the war's outcome. American forces were already positioned throughout the Pacific. Disrupting the canal wouldn't prevent the planned invasion of Japan or halt the bomber offensive. At best, the attack might delay some naval deployments by forcing ships around South America, adding perhaps 2 weeks to transit times. This minor inconvenience couldn't compensate for losing Japan's largest, most technologically advanced submarines and their highly trained crews. Commander Ariizumi understood the mission's futility. In conversations with I-4O's officers recorded in several crew members' diaries, later recovered by American forces, Ariizumi reportedly stated that Operation Hikari was more symbolic than strategic. The mission would demonstrate Japanese determination to strike American territory even after losing control of the Pacific. It would show that Japan retained offensive capabilities despite overwhelming enemy superiority. Most importantly, it would allow the submarine crews to die honorably in combat rather than surrendering or being destroyed uselessly in port. The submarines departed Japanese waters in late July 1945. I-400 and I-401 left from Ominato Naval Base on northern Honshu. I-14 departed several days later carrying additional fuel and supplies. The operational plan called for the submarines to rendezvous at a point 300 miles east of Hawaii before proceeding toward the Panama Canal. The submarines would maintain radio silence throughout the transit, communicating only in emergency situations using pre-arranged codes. American signals intelligence detected the submarine's departure, despite Japanese radio silence. Direction-finding stations throughout the Pacific picked up brief transmissions as the submarines navigated toward their rendezvous point. The transmissions were encrypted using Japanese naval codes that American cryptanalysts had broken years earlier. Decrypted messages revealed that several large submarines were at sea, apparently heading toward the Central Pacific, but didn't specify their mission or final destinations. Admiral Chester Nimitz, Commander-in-Chief Pacific Fleet, ordered increased anti-submarine patrols throughout the Central Pacific. The cryptic nature of the intercepted messages suggested a significant operation, possibly an attempt to attack American logistics hubs or conduct reconnaissance before Japan's anticipated surrender. Destroyer escorts equipped with sonar and Hedgehog anti-submarine weapons deployed to areas where the submarines were most likely to transit. Patrol aircraft intensified searches along projected submarine routes. The hunters were searching for their prey, but the ocean's vastness made detection improbable without more specific intelligence. On August 6, 1945, the B-29 Enola Gay dropped an atomic bomb on Hiroshima. The explosion destroyed the city center and killed an estimated 70,000 people instantly. 3 days later, on August 9th, a second atomic bomb devastated Nagasaki. On the same day, the Soviet Union declared war on Japan and launched a massive invasion of Manchuria. Japan's strategic situation, already hopeless, became impossible. The Supreme War Council met on August 9th and 10th to debate surrender terms. Emperor Hirohito, breaking the deadlock between military officers who wanted to continue fighting and civilians who recognized the futility of further resistance, ordered Japan's acceptance of the Potsdam Declaration. On August 15th, Hirohito's surrender broadcast was transmitted throughout Japan and to military forces overseas. All offensive operations were to cease immediately. All military forces were ordered to stand down and await instructions from occupation authorities. Commanders at sea received orders to surface their vessels, destroy all weapons and sensitive equipment, and proceed to designated surrender points for formal capitulation. Commander Arizumi aboard W400 received the surrender orders via radio transmission on August 15th while submerged east of Hawaii. According to accounts from crew members later interviewed by American authorities, Arizumi gathered his officers to discuss the situation. The operation was cancelled. The war was over. The submarines could continue toward Panama and execute the mission as a final act of defiance, knowing they would never return. Or they could comply with the emperor's orders and surrender. Arizumi reportedly told his officers that disobeying the emperor's direct command was unthinkable. Japan had surrendered. Their duty now was to preserve their crews' lives and turn over their vessels to occupation authorities. But first, they had to destroy everything that might give the enemy intelligence about Japanese submarine technology. The destruction process aboard I-400 began immediately. Crew members removed all 3 Seiran aircraft from the hangar, brought them onto deck, and disabled them. Wings were torn off. Control surfaces were smashed. The aircraft were set on fire to destroy any remaining useful components before being pushed overboard. Intelligence documents, code books, and operational plans were burned or weighted and thrown into the ocean. Torpedo firing mechanisms were disabled. The deck gun's breech was damaged to prevent firing. Radar and sonar equipment had critical components removed and destroyed. The goal was to render the submarine non-threatening while leaving enough operational capability to navigate to surrender points. Similar destruction occurred aboard I-401 and I-14. Within hours, Japan's submarine aircraft carrier force had been effectively disarmed. The submarines that were supposed to strike the Panama Canal were now floating hulks awaiting capture. On August 29th, I-401 surrendered to USS Segundo in Tokyo Bay, the encounter described at this narrative's beginning. I-400 surrendered to USS Segundo 2 days later at a different location. I-14 surrendered separately. American boarding parties who inspected the submarines were astonished by their size and complexity. Lieutenant Raymond Stone, part of the initial boarding party on I-401, later described his first impressions in a letter to his family. "It's the biggest submarine I've ever seen. It's longer than our destroyer escorts. There's this huge cylinder running along the forward section that they say was an aircraft hangar. The whole thing is incredibly complex, way more sophisticated than I expected from Japanese engineering. They built something amazing here, but they never got to use it." American technical intelligence teams descended on the captured submarines immediately. Naval architects measured every dimension. Marine engineers examined the propulsion systems. Aviation specialists studied the aircraft handling equipment. Intelligence officers interrogated the crews about operational procedures and intended missions. The interrogations revealed Operation Hikari's details, confirming American intelligence assessments about planned attacks on the Panama Canal. But the interrogations also revealed the profound disconnect between technological capability and strategic effectiveness. Japan had built submarines that could theoretically reach any point on Earth and launch bombing attacks against any coastal target. But the submarines were too large to operate effectively in waters where American anti-submarine forces dominated. They were too complex to maintain reliably with Japan's degraded logistics networks. they consumed resources desperately needed for defensive operations. And critically, they couldn't influence the war's outcome, even if they successfully executed their missions. The captured RN 400-class submarines were taken to Pearl Harbor for detailed examination. American engineers spent months analyzing every system, documenting the design in comprehensive technical reports. The submarines represented capabilities that American forces hadn't achieved. No American submarine could carry and launch aircraft. American submarines were smaller, focused on anti-shipping operations and special operations support rather than strategic bombing. The I-40's range exceeded American fleet submarines significantly, but the examination also revealed critical weaknesses. The hull construction used steel of inferior quality compared to American submarines. Welding techniques showed inconsistencies that would reduce structural strength under deep diving conditions. The hangar doors remained vulnerable points that could fail catastrophically if damaged. The aircraft launching system required extensive setup time that would be impossible under combat conditions where surprise was essential. The torpedoes, while technologically advanced with their oxygen propulsion, were dangerous to handle and prone to accidental detonation. Most significantly, American engineers concluded that the fundamental concept was flawed. Building submarines to carry aircraft made sense only if the aircraft could meaningfully affect strategic outcomes. The Seiran floatplanes carried bombs too small to destroy hardened targets like canal locks. 3 submarines carrying 9 aircraft represented massive resource investment for minimal destructive capability. American planners calculated that the same resources could have built 15 conventional fleet submarines that would have sunk hundreds of thousands of tons of Allied shipping. The strategic return on investment was overwhelmingly in favor of conventional submarines over the aircraft-carrying variants. Soviet intelligence services demanded access to the captured submarines. The USSR was developing its own submarine fleet and wanted to examine Japanese submarine technology. American authorities refused, citing security concerns and technical classification issues. The real reason was simpler. American submarine technology had advanced significantly during the war, and allowing Soviet access to the I-400 would reveal capabilities that the United States wanted to keep secret from its increasingly problematic wartime ally. In June 1946, the Navy decided to dispose of the captured submarines. I-400, I-401, I-14, and I-201, another advanced Japanese submarine, were taken to sea off Oahu. On June 4th, American submarines and surface vessels used the Japanese submarines as target practice. Torpedoes struck the massive hulls. Depth charges bracketed the targets. Within hours, all 4 submarines had sunk to the ocean floor. The vessels that represented Japan's last attempt to strike American territory directly became artificial reefs off Hawaii. The disposal reflected multiple considerations. Storage was expensive. Maintaining the submarines in non-operational status required resources. Security remained a concern, while Soviet representatives pressured for access. Most importantly, American submarine development had moved beyond anything the Japanese boats could teach. Nuclear propulsion was being developed. Guided missile systems were planned for submarine deployment. The I-40's represented the apex of conventional submarine aviation concepts, but that concept was obsolete before the submarines were even completed. Commander Ariazumi never witnessed the submarine's destruction. On August 29, 1945, hours before surrendering the I-401, Ariazumi locked himself in his cabin and committed suicide. His body was buried at sea by his crew before American boarding parties arrived. The decision reflected his understanding that Japan's surrender meant permanent defeat, that the submarine warfare campaign he had devoted his career to was finished, and that occupation by foreign forces represented unacceptable humiliation. His suicide note, recovered from the submarine and translated by American intelligence, reportedly expressed regret that I-401 never executed its intended mission, but acknowledged that the mission was militarily pointless. The Panama Canal attack would have achieved nothing strategically significant, even if completely successful. Japan had already lost the war through industrial inferiority, strategic overextension, and underestimating American determination. Post-war Japanese naval officers, who survived the submarine campaign, reflected on the I-400 program with mixed feelings. On one hand, the submarines represented remarkable engineering achievements, proof that Japanese industry could produce vessels matching or exceeding anything Allied nations built. On the other hand, the program consumed resources that should have been used for defensive operations or conventional submarine construction. Captain Zenji Orita, who commanded several submarines during the war and authored post-war memoirs about the submarine campaign, wrote that the E-400 program exemplified Japan's strategic confusion during the war's final years. Instead of accepting that the strategic situation was hopeless and negotiating surrender while retaining some negotiating leverage, Japanese military leadership pursued increasingly desperate plans that consumed scarce resources without materially affecting outcomes. The I-4Os became symbols of this desperation, technological marvels that served no useful strategic purpose. American submarine development influenced by the CEAS I-400 examination focused on specific technical elements rather than the overall concept. The long-range capabilities impressed American planners, but nuclear propulsion would soon provide unlimited range at higher speeds. The aircraft launching concept was rejected because guided missiles offered better solutions for striking distant targets. However, specific engineering details influenced American designs. The streamlined hull shape of the I-400 reduced underwater drag compared to earlier submarines with excessive external fittings. American post-war submarine designs incorporated similar streamlining principles. The pressure hull construction techniques, despite using inferior steel, showed efficient use of curved sections that reduced weight while maintaining strength. The electric motor systems demonstrated effective power distribution strategies. The broader influence of the I-400 program appeared during Cold War strategic planning. American military planners faced similar challenges projecting power against a peer competitor, the Soviet Union, that controlled the Eurasian landmass. Submarines offered advantages for covert operations, strategic reconnaissance, and potential attacks against hardened targets. The Navy developed submarine-launched ballistic missiles, creating underwater platforms that could strike enemy territory from international waters without warning. This capability mirrored Japan's intent with the I-400 program, using submarines to deliver strategic attacks against distant targets. The critical difference was that ballistic missiles carrying nuclear warheads could destroy entire cities or military installations with single strikes, providing strategic impact that justified the massive investment. The I-400 program's failure offered lessons about technological innovation versus strategic effectiveness. Advanced technology means nothing if it can't be applied decisively at the strategic level. The submarines were engineering marvels that consumed years of effort and scarce resources, but couldn't influence the war's outcome. Japan needed conventional submarines, merchant ship construction, air defense systems, and defensive fortifications. The I-400 program diverted resources from critical needs toward prestigious but strategically irrelevant weapons. This pattern repeated throughout Japanese military planning during the war. Super battleships like Yamato and Musashi consumed resources equivalent to dozens of aircraft carriers or hundreds of escort vessels that Japan desperately needed for convoy protection. Advanced fighters like the Shinden and Seiran were developed when Japan needed simplified designs optimized for rapid mass production. Kamikaze programs consumed aircraft and pilots that could have been used for conventional air defense. The pattern reflected institutional culture that valued technological sophistication and tactical excellence over strategic effectiveness and operational sustainability. The discovery of the I-400 submarine's wreck sites in 2013 by the Hawaii Undersea Research Laboratory brought renewed attention to these vessels. The submarines rest approximately 2,300 feet below the surface, their hulls remarkably intact despite 67 years submerged. The hangar doors remain sealed. The conning towers stand upright. The submarines appear ready to continue patrols that ended decades earlier. The imagery from remote-operated vehicles exploring the wrecks shows vessels frozen in time, their technology obsolete but their physical presence imposing. Modern Japanese historians studying the I-400 program emphasize its context within Japan's broader strategic failures. Professor Ikuhiko Hata, a naval historian at Takushoku University, argues that the program exemplifies how Japanese military leadership misunderstood modern industrial warfare. They believed that superior tactics, advanced technology, and warrior spirit could compensate for industrial inferiority. The mathematics never supported this belief. American industrial production exceeded Japan's by factors of 5 to 10 across virtually every category. No amount of tactical innovation could overcome such fundamental disparities. The I-400 submarines, capable of reaching any ocean and striking any target, couldn't compensate for Japan's merchant fleet being systematically destroyed by American submarines, built in greater numbers with superior technology. The legacy of the I-400 program lives in museums and technical archives rather than operational naval forces. The only surviving Seiran aircraft, recovered from lake bed in Japan, where it was hidden after the war, sits in the Smithsonian's National Air and Space Museum. The aircraft, fully restored, shows the ingenuity of its folding design and the quality of its construction, but it also reveals the fundamental compromise inherent in submarine-launched aircraft. The Seiran was smaller than land-based bombers, carried fewer bombs, had shorter range, and required extensive ground handling time to prepare for flight. These compromises made the aircraft less effective than conventional bombers, while not compensating through strategic advantages. Technical documentation from the I-400 program, declassified in the 1990s, fills archives at the Naval History and Heritage Command in Washington, D.C. Engineering drawings show every detail of the submarine's construction. Operational reports document training exercises and the aborted Operation Hikari mission. Interrogation transcripts record crew members' explanations of how the submarines operated and what missions they were designed to execute. The documents reveal a pattern seen throughout military history: technological innovation without clear strategic purpose, ambitious engineering projects that consume resources without providing commensurate benefits, and the disconnect between what's technically possible and what's operationally useful. The men who served aboard E-400 and I-401 received little recognition in post-war Japan. Unlike Army veterans or kamikaze pilots who became subjects of memorials and historical studies, submarine crews largely disappeared into civilian life without public acknowledgement. Many struggled with the knowledge that their service, their training, and the sophisticated vessels they operated contributed nothing to Japan's war effort. The submarines never fired shots in combat. They never executed their intended missions. They surrendered without inflicting any damage on American forces. Captain Nambu, who commanded I-401, returned to civilian life and rarely spoke about his wartime service. When interviewed by historians in the 1970s, he acknowledged that the submarine represented impressive engineering, but questioned whether the resources invested in its construction could have been better used elsewhere. He noted that building I-401 required steel equivalent to 3 fleet destroyers, engines that could have powered escort vessels, and skilled workers who could have built conventional submarines. The strategic return on that investment was zero. The submarine accomplished nothing operationally and surrendered without contributing to Japan's defense. For American submarine veterans who later learned about the I-400 program, Reactions ranged from admiration for Japanese engineering to bewilderment at the strategic thinking behind the program. Rear Admiral Eugene Fluckey, a Congressional Medal of Honor recipient who commanded USS Barb during aggressive patrols that sank numerous Japanese vessels, commented in his memoirs that Japanese submarine doctrine fundamentally misunderstood submarine warfare's purpose. Submarines should attack merchant shipping, disrupt supply lines, and force enemies to divert resources toward anti-submarine warfare. The I-400 submarines were too valuable to risk in routine commerce raiding, but not capable enough to influence strategic outcomes through their aircraft strikes. They represented a weapon without a viable mission, built because Japanese doctrine valued offensive action and technological prowess without considering operational practicality. The mathematics of the E-400 program tell the story most clearly. Each submarine cost 45 million yen and required 23 months to construct. They consumed 8,900 tons of steel, 1,200 tons of aluminum and copper, and countless specialized components. The 3 operational submarines represented investment equivalent to building 12 fleet destroyers or 36 conventional submarines. In exchange for this massive investment, Japan received 3 submarines that never engaged enemy forces, never executed their intended missions, and surrendered without firing shots. The strategic return was negative. Resources invested in the I-400 program were diverted from weapons that could have meaningfully affected the war's outcome. 12 additional destroyers might have provided more effective convoy protection, potentially reducing merchant ship losses that strangled Japan's war economy. 36 conventional submarines could have sunk hundreds of thousands of tons of Allied shipping, forcing allocation of more anti-submarine forces and delaying American offensive operations. Even investing equivalent resources in air defense systems, fortifications, or ground forces would have provided more military value than the Y-400 submarines. The program exemplified the strategic bankruptcy of Japanese military planning during the war's final years. Rather than accepting that industrial inferiority made conventional victory impossible and seeking negotiated settlement while retaining some bargaining position, Japanese leadership pursued increasingly desperate offensive schemes that consumed scarce resources without realistic chances of success. The I-400 program wasn't unique in this regard. The kamikaze campaign, the super battleship programs, the focus on advanced fighter designs rather than mass production, all reflected similar strategic confusion. The difference was that most of these other programs at least inflicted some damage on American forces, however disproportionate to their cost. The I-400 submarines accomplished literally nothing militarily. The forgotten heroes of the I-400 program aren't the officers who commanded these submarines, or the engineers who designed them. They're the factory workers, welders, and technicians who built sophisticated vessels, knowing that Japan's strategic situation made their efforts increasingly futile. They're the sailors who trained for missions that grew less realistic as American forces tightened control over the Pacific. They're the Seiran pilots who learned precision bombing techniques for attacks they would never execute. These people devoted their skills and energy to a program that military logic suggested was doomed from conception, not because they were stupid or ignorant, but because military culture and national propaganda demanded total commitment to offensive operations, regardless of practical feasibility. The E-400 submarines now rest on the ocean floor off Hawaii, monuments to engineering ambition unmoored from strategic reality, to technological capability without operational purpose, and to the profound truth that wars are won through industrial capacity, logistical sustainment, and strategic coherence rather than through impressive engineering or tactical innovation. Japan built the largest submarines the world had seen, vessels capable of circling the globe and striking targets anywhere on Earth. But these magnificent machines couldn't compensate for fundamental strategic failures that doomed Japan's war effort from its inception. The submarines were obsolete before their construction was completed, not because their technology was outdated, but because the strategic concept behind them was fundamentally flawed. They represented Japan's last desperate attempt to strike American territory directly, an attempt that ended not in combat or heroic last stands, but in surrender and scuttling, the final admission that technological prowess alone cannot overcome industrial superiority, strategic overreach, and the inexorable mathematics of modern warfare.